My name is Cedric, and in this lab, we are going to be incorporating several types of ideas, which include um being able to produce a voice, right? And this voice has different pronunciations, right? Meaning that we're going to have to place specific values, specific 8-bit values to be specific, that would allow a certain pronunciation, like syllables like A, E, I, O, U, you know. Um, but this list um, is pretty much this list here that relates to the hexadecimal values that go along with these pronunciation, and as well as pauses that we can incorporate, right? And so since I'm going to try to incorporate my name into this, right? So breaking it down, there's different files in each of these, right? This is the main file that we will be using to essentially allow chatter to be incorporated, um, and where pretty much I was able to pronounce my name by again referencing this here, and by its respective hexadecimal value of its pronunciation, I essentially just placed it into these case values here, which is basically um, this narrator. The way it happens is that uh, after every counting cycle, it goes by each case essentially, and that's how it pretty much follows, to put it simply. Um, but of course, there's more in the background because um, the main problem that we're going to be trying to follow is the FSM, right? Which is incorporating like how are we going to be when are we going to be transferring the data in order to in order for an audio output to be done, right? Because this transfer of data is very essential, right? Um, which is going to be here in this FSM file, but just to go one by one, each of these, right? This one we had to create a block memory generator, which essentially just allows us to uh, go after the phonemes, file, and it's a coefficient file, and this coefficient file is containing the different values that will be stored in the ROM, which we're going to be utilizing. Okay, and then this file goes over how it's going to go from digital to analog, and so this is where we come in. We're going to be covering more like how we're going to be transitioning from state to state, so that there's actual output. Okay, so just to reiterate, um, in order for there to be in order for us to actually produce audio, right? We have to go from it at a point that it's idling, so like it's waiting for something to occur, right? And so then we progress to, okay, now it's not idling, but now we're waiting for data to be arriving, right? And once data actually arrives, when it first initially arrives, we're gonna go towards that certain specific memory address, right? Um, that we're demanding, right? And so now, um, now what would occur is now the ROM is going to be waiting for that data after a set amount of time, and after that set amount of time, it's then going to capture, okay, and then after capturing, it's going to fetch the data, and the address pointer is going to increment, okay, and it's going to keep on incrementing until there's a matching address when the last address um, of the continuous incrementing, right, matches with the last address for what we're demanding, I guess, if that makes sense. But anyways, so going over in this fashion, essentially, to create this FSM file, we have busy, we have period expired, um, data arriving, value match, which is important because we want to make sure we want to check the values, the memory addresses to make sure that if like the last corresponding address matches with the address that the program is looking for, then it's just gonna basically stop, right? Um, right. So and then we're gonna want to load these pointers, these memory addresses, so then we can essentially just respond to the data that we want, right? And then of course we have the increment, the sample capture. Um, and so each of these FSM states, um, yeah, each of these states are corresponding to these respective outputs. So busy here is corresponding to when it is not in idle, right? And then we're going to be loading this load pointers is corresponding to load pointers that I've initiated here, right? And then we would have increment corresponding with that value of increment, and the sample capture corresponding to the capture variable there, right? So this is the output logic here. But to correspond to what we were following here, we're going to be going through this created FSM, right? And going along with this FSM here, uh, we're going to be seeing that that first it's an idle, so it's waiting for something to occur, right? So when we're in idle, then data is going to arrive, right? So if data arrives, then we're going to load the pointer, right, as our next state, right? And of course, if nothing is to occur, right, then we're still going to be in idle, right? But once, but once we're not in idle and we're waiting for that arriving data, right, then we're going to load into pointer, load pointer, right? And so now we're waiting on the ROM to retrieve those that data that we want, the the uh, the the phonemes addresses, right? And so now we're gonna essentially now capture. Oh no, we're not gonna capture. My bad. No, we're gonna be waiting on the ROM, and then once we wait on the ROM, right? It's gonna take a certain period to do so, right? And once that period expires, then we're gonna capture the data, right? And then after that period expires, right, then we're going to start incrementing those memory addresses to get the data that we want, right? And until there's a matching value to the certain address that we want, then we're pretty much going to stop there. And then we're going to idle again, right? Uh, but if we're not, if we didn't like catch that memory address, then we're going to keep on waiting on the ROM. We're going to keep on searching for the specific uh, phonemes that we're looking for, right? So basically, we're just going through each of the memory addresses to see which one we want. We're fetching it, we're fetching, and then it's just gonna grab it, and then we're gonna be using it, right? And that's what the capture is doing. And if we want to keep looking for what we want, right, then we're gonna start incrementing, and then that's what it's gonna be doing while it's busy, right? And then once it's done essentially fetching, right, then it's gonna be and because once it's done fetching, there's gonna be a value match for the memory address, and so once the value matches, then we're gonna basically go back to idle, and then this cycle just repeats. It's just as simple as idle wanting to uh, load the specific pointer from the data arriving, right? And then waiting on the ROB to scavenge what we want to fetch, what type of memory address we're going to want to fetch, right? And then we're just going to be incrementing throughout those memory addresses to get what we want. we're fetching, and then after fetching, um, if there's an address match, then we're gonna want to proceed with that, right? And so that's the logic on like how this problem was solved. At least that's what made sense to me, right? And so to verify our design, I'm gonna play uh, this audio here. Okay, so now that I've already played the audio, I actually learned a lot. This assignment helped me to actually understand the uh, how everything actually works uh, from like the FSM, because it the FSM here doesn't look too complicated, but it took a while to unwrap what was actually happening, and it was pretty cool to see something simple as like this code, very simple, right? Being able to produce a signal, right? The audio signal. So I thought that was pretty interesting. It did allow me to be more comfortable with the FSM, which was great to see. Um, I also found it interesting how we were able to use these uh, the block memory generator, which allowed us to create a this file here. But it essentially allows us to create like a file that is to represent like the ROM, um, from my understanding. So I thought that was pretty cool to utilize, as well as I assume in future projects you're going to be utilizing big pieces of data. So that was pretty good to get some hands-on experience on too.